Hello, CCR scholars. This is skill 3, which is converting factored form to standard form. So just to kind of review here, we have 3 major forms of quadratic. So we're going to write down what they kind of look like in general, and then also specific examples as well, just so you can see them side by side. So a general form of a factored form could be like a x minus b times x minus a. And a specific example, maybe I'll play around and have like a 2x minus 1 times x plus 5 or something like that. So that would be a specific example. So that is something that is created by the process of factoring. And we might want to be using these for like finding things like those x-intercepts. The standard form is nice to help us see what the a value is. It is like ax squared plus bx plus c is the standard form. And the plus c, as we will later learn, is the y-intercept. So when we have standard forms of polynomials, it is really nice to have because we can read off the y-intercept by just looking at that constant number. So a specific example could be, 3x squared plus 5x plus 7 or something like that. And in the vertex form, this, like the standard form, has an a, but we can kind of read off the vertex of the parabola. So I could have, for instance, 2 times x minus 4 squared plus 3. So these are the major forms of quadratic. So we're really going to hone in today on our end destination, which is standard form. So the a value, and just as a recap here, we have ax squared plus bx plus c. And what is of use for us here, the a value is going to give us the width and the direction of the parabola. Then the b over 2a is going to give us, or about negative b over 2a is going to give us kind of like that line of symmetry. Or we could also say the x coordinate of the vertex as well. And then the c value is going to give us the y-intercept. And I'll just kind of abbreviate that. So for instance, I'm going to draw this line of symmetry in here. So this is gotten because in this particular example, our opposite of b over 2a is going to be negative 2 over 2 times 1. So that's just going to get us to 2 over 2, which is equal to 1. And that gives us our x coordinate, or our line of symmetry. And then our y-intercept happens to be negative 3. And I just kind of marked on the graph there. So these are the uses of the standard form that are pretty helpful to know for those SAT questions. All right, so let's kind of take a look at some delta math examples here. First type of problem that I'm going to give you on delta math are the polynomial multiplications. We're just going to kind of use the distribution method. Sometimes in Algebra 2, people have done like the box methods as well, but good old distribution is good for these. So maybe what I would do here is I would just distribute the 2. So I would write this as 2x minus 16. And I would multiply that by x minus 4. And I still have some multiplication to do. I'm going to do 2x times x. So that's going to get us to 2x squared. Then I'm going to do 2x times minus 4. So that's going to get us to a minus 8x. Then I'm going to do a minus 16x. And then I'm going to do minus 16 times minus 4, which is plus 64. And I still have some like terms to combine. So this is going to get us to negative 8x minus 16x. So that's going to get us to 2x squared minus 24x plus 64. So we have gone from, a factored form into, kind of that ax squared plus bx plus c. And there we go. Other types of situations where you would see this computation is if I just asked you to simply do polynomial multiplication. All right, example 2, this is vertex to standard form. So the first thing you always want to do is expand what is inside your parentheses by squaring it. So x minus 1 squared is the same thing as x minus 1 times x minus 1. And then I have a minus 8 as well. And so this x minus 1, I'm just going to kind of circle it and show you where exactly it came from. The x minus 1 times x minus 1. It came from expanding that x minus 1 squared. All right, and then we're just going to distribute. And just take one at a time. So I'm going to do 3x minus 3. And then I'm going to do x minus 1 minus 8. And then I have a minus 3x minus a 3x plus 3 minus 8. And I have some like terms that I need to combine. So I have minus 3x minus 3x. And our final answer, we're just going to have in the ax squared plus bx plus c. It's just going to be 3x squared minus 6x minus 5. And then we're done. All right, now let's kind of look at the SAT version of this problem. So we're just going to kind of build. Actually, in reality, the computation for each of these three types of problems are exactly the same. So a basic algebra class problem, maybe in algebra 1, is just to ask you to simply multiply. And sometimes they put the negative sign out of a parentheses just to give it up a notch. But I'm just going to kind of change the sign. So make this negative x plus 2 times x plus 4. And I'm just going to distribute. So I have negative x squared plus 4 or minus 4x. So plus 4 times minus x is minus 4x plus 2x plus 8. And then I'm just going to combine those like terms. So the minus 4x and the plus 2x combined to minus 2x. And I'm just going to have negative x squared minus 2x plus 8. And that is the final answer. And the harder version is convert into standard form. And it is the exact same solution, believe it or not. Now, here's the SAT problem. So I'm just going to kind of change to the SAT version of this type of problem. And I'm just going to kind of internalize the answer we got on the previous page. So I got negative x squared minus 2x plus 8. And let me just erase everything for the computations. So it's asking us which of the following is an equivalent form of the equation of the graph shown in the XY plane, for which the y-intercept can be identified. So this is the buzzword for convert to standard form. And the y-intercept is a constant in this case. So vertex form, we have a constant, but the problem is that that's the y-coordinate of the vertex, not the intercept. This gives us the x-intercepts. But this problem, C and D, would be ones that maybe I didn't eliminate. But D is just kind of the missing a sign going on. So it has to be C. So thank you very much for listening in. There will be a few U-try problems, and then you'll get some practice on Delta Math today, converting into standard form.